Good morning, everyone. Probably most of you know me because I'm with AMS-IX for a while. But if not, my name is Maxx, and I work for a long time here. Today, I'm not going to do the update. I will try to build a story about our internal development project. First of all, I want to just remind you about a pretty unique setup that we have at AMS-IX, where we have two provider edge devices with one connection to the customer. And this device is actually layer 1 switch. We connect customer there for in order to save customer connection during the outage or backbone failure or optics. So let me briefly show you how it works. It is quite complex and precise device. On the screen now you can see the dry camera. It's actually pretty small, where you have the movable mirror array, where we can actually adjust position of mirrors, and the light goes out on the different output ports. Here you will see how it works. So at the bottom you have the movable mirror array. The light goes in, reflects from the small mirror, and then goes to the fixed mirror on the right side. Then it reflects back to another mirror, and voila, we have one customer connected. As you can see on the red line, it goes to the... oh, you cannot see it. Now you can see it. I see here just different slide. So now it's connected to the right customer. But what if we just slightly adjust the mirror position at the bottom? We'll have this situation. You can now see that it's flapping like this, like this. This swap is actually pretty fast. It's less than 25 milliseconds. And you, as a customer, can notice only the port flap. The BGP session is still alive at any position. So what we use now? We have now Glimmer glasses, Glimmer Glass X Connects. They have been proven as really reliable devices, which helps us to save connections when we internally experience some problems. Everything is fine as well, and they're still working. But the problem is that the Glimmer Glass as a company went bankrupt a couple of years ago. But they're still working. We have around 70 devices around the platform, but we're expanding, and we need new devices. We need to find something new for that. What we did, we started looking into some development projects, and started kind of project, a home project for fun, I would say. We found relays which do the similar function. It just swaps customer between two outputs. So as you can see on the screen, inside this relay is a stepper motor with a mirror. It just reflects light to one output or another. And yes, after some Googling, we found a couple of vendors of these optical relays. Of course, they cannot do, like Glimmer glasses, any-to-any mapping, so we cannot place the loop toward the customer once the customer requests that. But it's, with some aspects, they're even better than Glimmer glass. First of all, they're latching. This means that if device loses power, the customer's connection are not affected, which happens quite a lot with Glimmer glasses. Second one is 1310 to 1650 nanometers, which actually can cover also the normal connections for the plus CWDM. So we can use it with that. Insertion loss is really good. It is by specification, is from 0.5 till 0.8 dB. And the most important thing, they're really cheap. So Green flag was raised, and we started this development project. We've bought all these things that you can see on the screen, including the soldering machine. And when you think about some home project, you can think about what? Arduino or Raspberry Pi? That was fun. I was doing some things with Raspberry Pi before, so that was quite easy for me. Yeah. This is actually the picture at my home table when I was doing that. A couple of months of research, soldering, mounting, connecting, software writing, and we've got the first working prototype. Actually, you can see it in the hallway now. It's one REQ for 2 customers, but without the light readings. And for a proof of concept, that was more than enough. So we put it in the lab, connected to the switches, and they showed perfect results. So then, proof of concept has been successfully done, so we decided to build something more similar to the production unit. So we started design of 4U device with LC connectors. Yeah, this is the minimum viable product. At the end, after some designing, we realized that 4U is too much because the rack space is quite expensive nowadays. So then we had to do something smaller. To save space on the front panel, we decided to go with MPO cables with a breakout, as you can see on the screen. So one connector can serve 6 customer connections. We used MTP12 in the MVP product, so for the exactly 6 customers on one cable. So at the end, we designed a 2U chassis, and we made it modular, which actually made it more flexible to use. And as a heart of this device also was Raspberry Pi, at that moment 4. Yeah, I think it's still 4, right? This is the minimum viable product which we built. So we made the design, we built it on the factory. So it took actually a couple of years journey. At the end, we had this chassis with 8 modules, relay modules, 1 power supply and 1 management module. Each module could serve 12 customers and 8 modules, which means it's 96 customers per 2U device. Actually, this is similar to 288 ports glimmer glass connection. Yes, on this stage, MVP project was announced as done because it was working in the lab perfect, but it was not ready enough for the to put it into production. Because we need the proper official hardware software testing and the certification. In order to fix this missing part, we submitted RFP to the couple of hardware companies, development hardware companies, which should perform additional design improvements, fix our mistakes, develop secure software, compliance testing with appropriate certification. And one company won this RFP, and this company is based in Ukraine. We made a contract with Teratel company Q4 2021, before the full invasion, and you can realize how it was scary for us what is going to happen because of this war. But they did great job. They built brilliant units with a perfect software, but on software part we're still working because it's still beta testing. So last November we got finally 2 lab units. We put them in the lab and they were perfect. We went even further on these devices with Teratel than MTP12, so we used MTP24, which means we can put more customers behind one physical port. At the end, we built modules which can support 16 customers. And these devices are there. So we have two flavors of devices, one U chassis with 4 modules, which means it can serve in total 64 customer connections. Actually, this is full reflection of the biggest Glimmer Glass PXE 192. And 2U chassis with 10 modules, which means 160 customers per 2U, which is a really dense solution. We can still extend it, but for now it's fine. Actually, yeah, 160 customers is a reflection of 480 ports Glimmer Glass, which never exist. Yeah, so software part. This is the web interface of this unit. We are still working on it. We are improving it. You can click, you can you can swap customers using this one, or you can use REST API in order to automate this solution. Work is still ongoing, but hope we will have it in production till the end of the year. This was my short story, so if you have any questions, please ask, or you can catch me later.